In this video, we'll be creating the large drive sprocket for the bulldozer. This is an interesting separate part, and I'm going to create a cylinder for this as a base. And what's very important with this cylinder is that since I want to model everything in one part, so I need to make sure that first of all it's in the correct position, but secondly that I have the correct number of segments. And you can see me changing the segments here. I'm choosing 30, and the reason for this is you can see those three cylinders. I'm going to have to divide the surface into three parts, and for that I need a multiple of 3. And I'm starting off by creating the base divisions with a few insets. This inset should mark the end of those cylinders, and that should be the center cylinder. Once I have that, I'm selecting the polygons that will make up those 3 cylinders. It's an interesting shape. It's actually a cylinder with 3 extra cylinders on the side. And I performed an inset here, but I need to fix these edges just by eyeballing it and scaling things down slightly. Once that is done, I'm going to do the same technique as I've been doing for the past videos. Create a reference cylinder with the correct number of segments, placing it in the correct position. And once that is done, moving it slightly to the right position, I'm going to align the pivot to the large cylinder so that I can create 3 duplicates, heading 2 as a number of instances, and there we go. Now I just use the snapping tools as I've been doing all the time to snap all the verts into the correct position. Note that I'm ignoring the vertices at the bottom because these would disrupt the flow of my cylinder at the bottom. I'm actually going to scale this cylinder down till the edge matches those corners. Once that is done, I will snap the vertices again for each of the 3 cylinders. And once I've done that, I'm going to scale it up slightly and then perform an inset. Now that I've created the base framework for this shape, I'm going to select everything, and I want to start to create some 3D geometry here by beveling that inwards. That looks about right. Once I've done that, I see there's a slight problem here once I perform an outline. And to fix that, I'm just going to manually remove this loop again. Delete the complete inside, and then start selecting the vertices that have problems. Once I've selected these, I scale them in, convert my selection to edges, and scale the edges down. The difference is that I'm doing a scale for the total selection and then a scale for each part. That way I can just totally fix my shape. Then just another cap and things are fixed. That cap done, I'm performing another inset. And then I'm just going to use Swift Loop to start adding supporting edges so that I can have hardened edges over there. A small selection here because the reference showed that there is another extruded circle here or an extra bolt. I'm doing the same method here, creating an extra cylinder, moving it into the correct position. Once that cylinder is positioned correctly, I'm just snapping the vertices into the correct positions. Once that is done, an inset, then an extrude with a slight bevel and another inset, and we're done with that part. Once that's done, I want to start creating the more interesting geometry on the outside. There's a whole loop that's extruded slightly downwards and has a large amount of bolts on the outside there. Well, first of all, I'm adding the supporting geometry, and we're going to get to those bolts right away. I'm deleting the backside because I want to model some extra parts there. And now I'm going to create those 3 round parts with the 2 bolts on top that sit in the front area of the drive sprocket. These are interesting parts. They make it visually a very interesting form. I think it's one of the most interesting parts of the bulldozer. So I've created those, I converted them to a double poly, and note that I used a modifier and collapsed it. This makes sure that the instances aren't broken. Then I can just do some simple modeling with insets. Then I duplicate my bolt, and I'm going to move the bolt into the correct position. It's a little bit too big, so I scale it down. Then I will attach it to the main part, and every other instance is updating. Once that's done, I duplicate it, do a random rotation, and as you can see, each one of those green parts now has those 2 bolts attached. Then I'm attaching every part, selecting them, and again, performing a random rotation on them, but making sure my pivot is aligned correctly. Something like that. And they look random enough now. With that done, I'm going back to adding some more supporting edges. What I've done here is there's a slide inset on the back of this part, and I'm just using a scale to scale that down slightly. I'll of course need to add some supporting edges. Once those edges are there, I'm going to create an extra cylinder, and the cylinder will form the center part of the drive sprocket. This is another part that's a bit of a challenge to model, since there's these 3 cutout areas for bolts around the edge of the cylinder. I'm leaving the back side, and then selecting the front side and performing an inset here. And I'm selecting the areas where the bolt will be inset, and this looks wrong. I need to select there. That's one area. That's leaving the same amount between each 3 of them. Then I'm performing an inset here to create the basic cutout shape of the area for the bolt. And a grow for some easy selections, forming an extrude here. And as you can see, the shape is starting to form nicely. Another swift loop. With that done, I'm going to do an inset here. And there's an interesting beveled area in the center. Trying to get the right feel for it. It should be something like this. Then an extra inset, and with a swift loop I can add supporting edges where the edges should be hardened. Once that's done, I can attach this part to the main drive sprocket, and I'm going to take a look at it in TurboSmooth. And as you can see, some of the edges are too round. The center part has to be scaled up, so I still have some work to do. The main problem here you can see is these edges were absolutely too round. There's a sharp edge on the reference, and I want to replicate that. So I'm going to add a supporting edge here, but the problem is I can't add it with a single loop. I'm going to have to do it in a few tries. So I'm selecting 3 separate loops again here, moving them into the correct position. As you can see, there's an open area there. I'm going to select each of these sets of vertices, hit connect, and all of them are connected. And once they're connected, I can just use target weld on them. You can't use target weld with unconnected vertices, so that's why I'm doing that. Once that's done, I've also decided that the center of the main circle in the middle here needs to be slightly smaller. I think the area of those 3 cutout parts is a little bit too small. So I'm going to scale this inwards and stretch that area slightly, just like so. Once that's done, I think I also need to scale this area up slightly so that I have a nice rim there where I can add the bolts. Using a duplicated bolt model here, I'm going to align the pivot to the main cylinder. And once that's done, I can just scale this up slightly. I'm getting 1 bolt exactly how I want it. Once that is done, I'm going to use the array tool, set to a 360-degree X rotation on a 1D array. I'm just increasing the number of bolts to get a feel for what I like here. 36 sounds like a right number. Attaching all of them through attach list, because clicking each of them separately would be a lot of work. Then I'm just duplicating these extra bolts to the areas where they should fit into. Once that's done, I'm rotating them around with the correct pivot alignment, which is an easy way of getting them into the correct position. Adding some random rotations just to get the artificialness out of my model. And I'm adding some random rotations here also. I've set the pivot to be on a per element basis. Just selecting, deselecting some parts, rotating them. It's a bit tricky to get all of them random, but I can get some variation in them by rotating them in sets. Once that's done, I want to do some slight extra parts in the center here. There's an extruded area there that also has some bolts. So I'm just replicating those bolts from the side, moving them in here. And there's actually 3 of them. So that's how I'm creating them. This is quite an interesting area. And we need to add a few more details here. There's actually a bolt, well, not in that area there. And I'm just modeling this one because it might look better round instead of hexagonal. A few insets. Once that's done, I'm going to scale it up slightly because that will look better. And what I have here looks pretty good for the center of my drive sprocket. Next up is actually creating the sprocket teeth, which sit all around this center part, and they hook into the tracks and actually drive the machine. And as you can see me doing here, I've used the dot loop selection to select these separate parts, one every polygon, and that way I can create the teeth for the sprocket. These teeth are just adjusted simply with a few bevels, insets, and extrudes. I'm using Swift Loop to control the geometry slightly more. And then modeling some extra parts, some extra geometry with inset. This looks pretty good. What I need to do now is add an extra line of nuts here. These are slightly bigger, slightly chunkier. I need to move them around like that. And once I have them in the correct position, I can just do the same trick with array again. I'm going to use attach list to attach them. There we go, they're all attached. Once they're all attached, this is starting to look pretty good. I just need to fix up the rear area of the drive sprocket. This isn't so hard anymore. You won't really see a lot of this part, and I've actually decided to detach this to a separate element. And it's this sort of semi-beveled area that goes into a straight cylinder again. Once again, you won't see so much of this, so I'm just mainly focusing on getting the general shape right at the back. There's a slight edge also at the inside of the drive sprocket, which I'm going to try and get right. And once that's done, I'm adding some detail on the back. Detach this to another element, scale it down, and then perform another extrude and delete the back side of it. There we go. Once that's done, I'm going to create another extra very simple wheel, which is the main roller for the tracks. These rollers don't drive the wheels or anything, they just guide them at the front and the back of the tracks. They're quite simple. I'm just getting them into position here. Converting it to a polygon, selecting these both sides. And this is just very simple modeling using some insets, extrude, bevel. Scaling this down slightly. I'm trying to get the depth for the inside of the rollers exactly right. This is mainly just eyeballing. And I need to watch out that the center doesn't become too thin, that they start protruding into each other like you can see happen here sometimes. For that reason, I'm starting to extrude them outwards again. And it seems like this is an approximate height that I should be satisfied with. As you can see, making these simple wheels, not the ones with sprockets and details, is mainly just a game of a lot of insetting, extruding, and tweaking the settings correctly. These are pretty much the most simple kind of models you can create. Because the pins for the tracks have to slot into the center of these wheels, I'm creating a whole bunch of loops here that allow the tracks to be guided by these rollers. I'm adding some extra support geometry. And with that done, these wheels should be almost good. A slight adjustment might be needed for these loops, scaling them outwards. And with that done, I can just copy these to the front. And then I'm going back to creating a small detail at the top of the suspension. This is a really small part, but I'm just adding it into this video. I'm starting with a simple box, then adding some extra loops. And on the inside of this box, there's a sort of opened ring. This might be to attach a chain or a cord or something. I need to make these vertices planar and move them down. Once that's done, I'm selecting these and performing an inset. That inset done. Moving these vertices to create the perfect shape of the hole in the center. And I'm extruding that towards the back. I need to keep in mind that I'm using symmetry here, so I can leave the back open. Once that's done, I'm adding some more support edges, and this part should be almost finished. Now I just need to attach it to the main part. I'm performing a slight inset and adjustment on one end of this part, since we're going to be attaching the dozer blade arms to this. I'm preparing it slightly for once we get to that part. It's a sort of semi-spherical shape at the end. It's a simple model. And with that done, that's it for this video.